Once again, before we begin our video, I want to encourage you, please like my videos, please subscribe to my channel, and share my videos to your loved ones. So today we're going to talk about PDEs again. It's a continuation of our previous video when I solving a case where the constant is bigger than what? 0. That's case 1. Remember, I'm going to solve 3 cases. Case 1, when P is greater than 0. Case 2, when the constant is equal to what? To 0. Then case 3, when the constant is less than what? 0. So now here is a continuation of that previous video. Please follow my series on PDEs under my playlist. So let's continue with this. Now this is how we stopped in our previous video. We're going to now introduce the boundary conditions in this. So let's introduce the boundary conditions. So the first boundary condition we're going to introduce is this: when our distance x is 0, the whole thing is equal to what? To 0. The temperature is equal to what? To 0. The whole function is equal to 0 when x is what? 0. That's the first boundary conditions. In most questions, these boundary conditions are what? Are given. So let's substitute. Whatever it says, I'm going to put what? 0. So on this function here, at this point, I'm going to put 0. So it's going to be 0, the same as wherever this x, we're going to put, because our x is what? 0. Put here 0. So it's going to be a times e. Whatever the second be e to power 0 plus b e to power lambda times what? 0. So it's going to be 0. Then c e to power, this is a function of t, there's no problem, just copy it. It's going to be lambda squared, that's single square, then t. So you're getting very well, but you know e to power 0 is 1, so it's going to be 0 is same as a plus this 1 plus b e to power 0 is 1, so you leave it. Then c e to power lambda squared sigma squared, then t. Are you following very well? But now we're going to use the same property where the whole function in the bracket here is equal to 0, or this c is equal to 0, or this one is equal to 0. But in our solution, this c cannot be equals what? 0. Why? Because it's a value. Also, this exponential power, that is not equals to 0 because it's a value of its own. So it can't be what? It can't be 0. But now the only thing can be 0 is what? This bracket here. Why? Because these are what? Values of their own. So that means we have a plus b same as 0. So what is b? Our b is same as negative a. Very important. Now this is the first what? Boundary condition when what? X is equal to 0. So the second boundary condition is when x is equal to L. Let me write this here. UL T the same as 0. That means our x, if compare with this, our x is what? L. So that means here x is equal to L. So remember in our previous video, please go and follow our series. Our boundary conditions, so I'll get them. Consider a shaft of length L. Where here at point maybe P and then Q, at point P our x is what? 0. At this point our x is equal to what? To L. So in our boundary condition, so at this point here we consider x is equal to 0, then x equals L. So I finish when x equals 0, then I consider when x equals to L. So we substitute still in our equation. So whenever there's x, we're going to put L. So it's going to be the whole function is equal to 0 when x is equal to L. So it's going to be 0, the same as, follow very well please, a e lambda L plus b. Now our b is equal to negative a. From our previous, our b is equal to negative a. So you can substitute this for our value of b. Our b is negative a e to power negative lambda L. Are you getting very well? It's not hard, it is a simple thing. So we substitute wherever there is x, you are putting L. So you're going to put this, it's going to be c e to power that. So it's going to be lambda squared sigma squared, then t. Now I hope you can see that a is common, you can pull it out, it's going to be 0, same as a out, exponential lambda L minus e negative lambda L, then c e lambda squared sigma squared, then t. Now if you can see this, since c, a and this exponential is the values, they can't be equals to 0. That means this a, this and that, they are real values, so they can't be equals to 0. So that means our a cannot be equals to 0, our c cannot be equals to 0, then our exponential lambda squared, sigma squared, that cannot be equals to 0. When we have this, it will kill our what? Our expression. So, but these are values, they can't be equals to 0. But now the whole thing in the bracket can be equals to 0. That means E lambda L minus E negative lambda L is equal to 0. You can manipulate this. So this is going to be e to power lambda L, same as e to power negative lambda L. Very important, please follow very well. After that, you can divide all through by this. It's going to be divided by e to power negative lambda L. Follow very well, divided by e to power negative lambda L. So this can go, then remain 1. It's going to be this and that can be e to power 2 lambda L. This indices. You can subtract this minus that to get that. The same as 1. But so you know 1 in terms of this exponential, it's going to be e to power 0 because a number to power 0 is what? 1. So it's going to be e to power 2 lambda L, same as e to power 0. Very, very important. So if you compare bases, you find that this is same as that. So that means 2 lambda L is same as 0. But now 2 is a value, isn't it? 2 is not a value. Then our lambda is a constant. It can't be equal to 0. Then our L is like the length of the what? Our shaft. It can't be equal to 0. That means our 2 cannot be equal to 0 because it's a value. Our lambda is a constant, cannot be equal to what? 0. Then our L is the length of the shaft, cannot be equal to 0. Now, if you find that in our case here, we found no solution, meaning you now make a conclusion. Therefore, P, whether 0 is not a solution, the PDE is not the solution to the PDE. Why? Because it has no what? Solution. It does not satisfy our boundary what? Conditions. We are testing the boundary condition, but this thing has not satisfied the boundary condition. So it's not a solution to PDE because it does not satisfy, the boundary conditions. Have you seen that? So it's not a solution to this PDE. So we're going to try for case 2 when P is equal to 0 in our next video. Please like my videos, please comment my channel, and please share my videos to your loved ones. Watch out for next video in our playlist. We're going to talk about case 2 when P is equal to 0. Please don't forget to subscribe. Thank you very much.